Okay, in this video I'm going to provide a review of various functions to obtain descriptive statistics for a numeric vector. We're basically continuing on with our discussion of numeric vectors. In a couple of previous videos I demonstrated how to create a numeric vector and then utilizing various functions in R how to generate descriptive statistics. So we're going to in this review, we're just going to create us a new numeric vector, which I'm going to call interest. And we're going to use the C function to enter the values for this vector. So we'll type in this case, we'll type in 3, 5, 9, 12, and 15. And once we close off the parenthesis and hit enter, we can now look at our vector to see what the values are, and so there they are. And if we want to look at the structure of the vector, we'll type in str, the structure function, and the name of our data object, which is interest. And you can see that R is recognizing our vector as being numeric. So next, I want to generate some general descriptive statistics such as means, medians, standard deviations, and so forth. So we'll start off with mean interest to get the mean for our variable. We'll type in SD for standard deviation and our variable name enclosed in parenthesis. We'll type in median interest. Min for minimum value or the lowest value. So there it is. Max interest. And range. And there you go. So you can see that we get the minimum and maximum values for our variable. If I want to create a histogram, I can use the hist function and type in interest. And so now you can see a histogram appears, and you'll notice that we have at the top you've got a title, and then you've got interest, which is a label on the x-axis and frequency on the y-axis. We can change those if we want to by utilizing several arguments or including several arguments with our function. So we're going to type in hist interest, for example. We'll use main argument equals, then quotation marks. And then, and I'm using main if I want to change the title of the for my graph. So let's just say I want to call this student interest. So I have to put that in quotation marks. Then, if I want to change the X label, which right now it says interest, but let's say I want to change it to something else, I can use the XLAB argument. Then equals, and then quotation marks, and then whatever I want to change it to. So I could just say, let's just call it scores for lack of a better, more informative label. If I want to change the Y label, let's say right now it says frequency. If I want to change it, let's just say I'm going to change it to frequencies. I can type in down here, I can type in YLAB equals, and then inside the quotation marks what I want to change it to. So I'm going to change it to frequencies right here, and then in parenthesis, and then hit enter. And so now you can see our graph has a new title called student interest. The X label is called scores, and the Y-axis we see the label as being frequencies. Just keep in mind that by default, when we use the histogram function, you'll notice that you get frequency counts on the y-axis. If we want to change those to densities, we can do that, but what we'll need to do is to type in FREQ, that argument, and set it and say equals, and set it to false. If it's set to true, then basically we'll get the same thing as what we have right here. But if we set it to false and then hit enter, now you'll see that we get densities. So at any rate, you'll notice that I didn't include in this last demonstration, changing a title or the labels for the X and Y axis. But you can obviously add this argument right here to our syntax if we wanted to do that. So now what we're going to do is create a kernel density plot. To do this, what we'll do is we'll just create a data object. I'm just going to call it D, and then we'll type in the density. This is going to be a function, and then we type in the name of our data object, which is interest. So I'll hit enter, and then following that we'll type in plot D, and so now you can see that we get the kernel density plot. So just note that this right here, this is just the name of our data object, so it's arbitrary what you name it, but it does need to reappear right here with our plot function. So another thing that I've mentioned in the first two videos, or my previous two videos on this topic, I mentioned that we kind of went through right here, we kind of went through in a piecemeal fashion in order to generate various descriptive statistics. But one of the nice things about R is that there are a number of user-written packages that essentially reflect combinations of functions, so are a collection of functions. And so rather than sort of generating this information in a piecemeal fashion, we can utilize several user-written packages in order to generate the same information, and actually even more information, if we wanted to examine the distributional characteristics of our variable. So what we're going to focus on in particular are the psych package, paste CS package, and summary tools package. So and I've already installed these packages, and so they're ready to use. It's just that when you are using packages, once you've installed them, to be able to use them and to use the functions that are contained therein, you have to call it up. So what we use is a library function to call up a given package. So I'm going to use the psych package first. And so I've typed in library psych and then hit enter. And next what we'll use is the describe function. So describe is a function associated with the psych package. So you can't just, it's not a base function. It's not a function that stands outside of a package, but rather describe is written for psych. And so if I want to generate descriptive statistics, then I can just type in my object name, interest, and hit enter. And so now you can see that we have the sample in, mean, standard deviation, mean, and so forth. There's standard deviation and so forth. If I want to use the paste CS function, then our package, now I can type in library and hit enter. And so now we can use a function under that, which is stat period DESC. And there you go. So now you can see that we have a number of the pieces of information that we had obtained above, and also within the psych package. Now another package that's available is the summary tools package, and I like this one in particular. So I've just called up the summary tools package, and I'm going to use the its describe function, but it's spelled DESCR, and then the variable name interest. So we'll type that in, and so now you can see that we have the descriptive statistics, and I kind of like the way it's sorted. It's kind of ordered here than as opposed to some of these other packages. So at any rate, if you want to get frequency distribution, you can type in FREQ and then interest, and there you go. So just note that this function right here and this function right here are associated with the summary tools package, which is this right here. Now just a couple of final functions that I want to talk about that are not part of the any of these packages, but rather they're part of the base R program. We'll start off with QQnorm, and if we type in our interest data, our vector name, you can see that we get a normal QQ plot, and if I want a fit line, I can just type in QQ line, and there you go. So now we have that. And if I wanted to obtain a box plot, I can just type in box plot and interest, and so there you go. There's our box plot. And you can use a you can use the main argument as well if you wanted to add a title and so forth. Finally, if I wanted to generate, let's say I wanted to test for normality or lack thereof, I could use the Shapiro-Wilk test to obtain test results. I can just type in Shapiro, period, test, and then interest. And so now you can see that I have the Shapiro-Wilk normality test.